Hello, we are Group Zoro.
Hello, my name is Mohammed Hamshamil Muhammad Irwai. I am 23 years old and I am from Kuala Lumpur.
Hello, Assalamualaikum. My name is Muhammad Iman bin Jabaruni. I am 23 years old and I am from Kedah.
My name is Ali. I am from Egypt and I am 23 years old. My name is Desian and I am from Selangor. My age is 25 years.
Hello, my name is Muhammaduddin bin Muhammad Rizal. I'm 33 years old and I'm from Terengganu.
The objective of this project is 1. To demonstrate the conversion of thermal energy into mechanical work in a controlled experiment. 2. To calculate and analyze the potential energy gained by the lifted load to quantify the mechanical work produced. 3. To provide a practical understanding of energy transfer efficiency in a basic steam propulsion mechanism. Now let's see the principles used in this project. 1. First law of thermodynamics. Conservation of energy. Heat energy from the stove is converted into internal energy, steam, which is then transformed into mechanical work to lift the load. 2. Second law of thermodynamics. Heat naturally flows from the heat source, stove, to perform useful work, and some energy is always lost due to inefficiency. 3. Newton's third law of motion. The steam jets out from the can in one direction, producing a reactive force that causes motion in the opposite direction, used to rotate or lift. 4. Gravitational potential energy principle. The lifted weight gains potential energy calculated by P equals mgh, allowing measurement of the system's mechanical energy output. In this section, we will demonstrate the working of our steam-powered lifting system. First, water is heated inside a sealed metal can placed over a stove. As the temperature rises, the water turns into steam, creating pressure inside the container. The steam then escapes through angled outlets or nozzles, creating a reactive force. This force is based on Newton's third law. For every action, there is an equal and opposite reaction. As the can rotates, the thread wound around it begins to lift the attached weight using a simple pulley mechanism. The lifting action demonstrates the conversion of thermal energy from the steam into mechanical work. As the load rises, it gains gravitational potential energy. Aelolipile. It is the first steam turbine invented in the 1st century AD by Heron of Alexandria. His machine consisted of a water reservoir with a heat source located underneath, and 2 copper tubes extended upwards from this reservoir, acting as the pivot for a rotating sphere. To the outside of the sphere, 2 nozzles were created from tubing bent out from the surface of this sphere, making an L shape. How does it work? The principle behind the machine relied upon steam from the heated water rising through the copper tubing into the sphere. This steam escaped through the nozzles at high speed, generating thrust according to Newton's second and third laws of motion, causing the sphere to rotate on its axis. Newton's third law states that every action has an equal and opposite reaction. So, as steam escapes through the nozzles at high speed, it generates a thrust on the tube with equal force, causing the sphere to rotate on its axis. A turbine is then formed as the energy of the moving liquid is converted into rotational energy.
うとうドーム外の戦い。勝者ゾロ。